A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, we have a really sticky one from Daniel today. He's looking at the plumbing of the AI agent world, specifically the NPM registry, and how developers distribute MCP servers. He's asking if you publish an MCP server to NPM and make it executable via NPX, can you actually pull off flawless, seamless updates for your agents? We're talking about the deep mechanics of NPX version resolution, caching, and how Semver actually behaves when an AI agent is the one calling the shots. Are these updates actually hitting the agents, or are they just silently running stale, cached versions while the developer thinks everything is fine?
Herman Poppleberry here, and Corn. This is exactly the kind of invisible friction that drives developers crazy. We're in this transition where the command line isn't just for humans anymore, it's the interface for autonomous agents. And when you take a tool like NPX, which was designed for a human sitting at a terminal, and you plug it into a headless configuration file for an AI, the assumptions that worked in 2018 start to break in very weird ways. By the way, fun fact for the listeners, today's episode is actually being powered by Google Gemini 3 Flash.
Well, hopefully Gemini 3 Flash doesn't have a stale cache of our personalities. But seriously, I've seen this play out. A developer pushes a hotfix to NPM at 2 in the morning because their GitHub MCP server is throwing errors. They see the version bump on the registry, they tweet out that it's fixed, and then 3 hours later, users are still complaining that the agent is crashing. It's like the update just vanished into a black hole.
It's not a black hole, it's the file system. Specifically, it's the NPX cache. Most people treat NPX like a magic fetch and run command, but it's actually a check if I have it, and if not, fetch it command. When an AI agent like Claude Desktop or Cursor looks at its configuration file and sees a command like npx middleware server, it's executing that in a non-interactive shell. If npx finds a version of that package in the local cache, which is usually tucked away in your home directory under .npm/_npx, it's going to run that version. It doesn't matter if you just published a newer one 5 minutes ago.
So NPX is basically a lazy librarian. If it has a dusty copy of the book on the shelf, it's not going to the bookstore to see if there's a revised edition. But wait, what if I use the latest tag? If I tell my agent to run npx my MKP server at latest, doesn't that force a check?
You would think so, right? That's the logical assumption. But the reality is much more frustrating. In the NPM ecosystem, latest is just a tag. It's a pointer. When you run npx with a package name and no version, or even with at latest, npx looks at its local cache first. If it has a folder labeled with that package name and a version that was previously resolved as latest, it often just stays there. There is a time to live, or TTL, for these caches, typically around 24 hours. So you could be stuck on a latest version from yesterday while the actual latest on the registry has moved on 2 patch versions.
That's a massive gap for something as dynamic as MCP servers. I mean, we're seeing these protocols evolve weekly. If I'm a developer, I'm essentially shipping code that my users might not see for a full day, even if they restart their AI agent. Does restarting the agent even help?
Generally, no. Most AI agents manage the lifecycle of the MCP server by starting the process when the agent app opens and killing it when it closes. But the start command is still just that npx string. If the underlying npx cache hasn't expired, the agent just spins up the same old binary. It's a silent stale problem. The user thinks they're on the cutting edge because they see at latest in their config, but they're actually running legacy code.
Okay, So let's get into the weeds of version resolution, because it's not just latest. Developers love their Simba ranges. If I put caret 1.0.0 in my config, how does NPX handle that versus the registry?
This is where it gets even hairier. Semver ranges like the caret or the tilde are designed to give you flexibility. Give me anything compatible with version 1. If you already have version 1.0.1 in your local NPX cache, and the developer just pushed 1.1.0, NPX is going to look at its cache, see that 1.0.1 satisfies the caret range and say, great, I'm done. No network request needed. It prioritizes the local satisfaction of the Semver range over the remote best match. It's optimized for speed and offline usage, not for the continuous delivery mindset we expect with AI tools.
So the speed optimization is actually a liability here. We're sacrificing correctness for the sake of not waiting 3 seconds for a metadata check, which, in the context of an AI agent that's about to spend 30 seconds thinking anyway, seems like a poor trade-off.
It's a terrible trade-off, and it leads to what I call the ghost tool bug. Imagine your agent's system prompt, which might be cached or generated based on a previous successful run, expects an MCP tool to have a specific schema. Maybe you added a new required argument in version 1.1. The agent knows about the new argument because it read the documentation or it's part of a newer model's context, but the server it's actually talking to is the cached 1.0 version that doesn't recognize that argument. The agent sends the request, the server barfs because of an unknown property, and the user is left scratching their head because everything looks right.
That sounds like a debugging nightmare. You can't even see the logs easily because these servers are running in the background, often piped directly into the agent's IO. You're not seeing the NPX output. You're just seeing the agent say, I encountered an error.
And that brings us to the Headless Hang, which is one of the most common failures for new MCP developers. Since NPM version 7, NPX has this safety feature where if it needs to download a package it doesn't have, it stops and asks the user, need to install the following packages. Okay to proceed, and waits for a Y or N.
But there's no one there to press I.
Not exactly, you're right. The agent is running this in a background process, there is no interactive terminal, so NPX just sits there forever waiting for a confirmation that will never come. The agent thinks the MCP server is starting. The user sees a loading spinner, and meanwhile, there's an invisible prompt sitting in a ghost buffer somewhere.
That's why you always see that -I flag in the documentation for the good MCP servers. If you aren't including npx-y, you're basically playing Russian roulette with your user's installation.
It's mandatory. If you're a developer shipping to NPM, your instructions must tell users to use npx-y package name. Without it, the zero install experience becomes a zero functionality experience.
Let's talk about the developer side of this. If I'm publishing to the registry, I'm usually just hitting npm publish and assuming my work is done. But you mentioned that the latest tag is mutable. Can you explain why that matters for someone trying to manage an MCP ecosystem?
Right, so when you run npm publish, npm automatically tags that version as latest. But let's say you're working on a big version 2.0 and you want to do some beta testing. You publish 2.0.0-beta. If you aren't careful, that might get tagged as latest, depending on your configuration. Or even worse, it might not get tagged as latest, and your users stay on version 1.5 forever even after you think you've released the new stuff. You have to be very intentional about how you manage NPM tags. If you want people to move to a new major version, you have to ensure that latest actually points to that new major version. But even then, we're back to the cache problem. Even if you update the tag on the registry, NPX isn't checking that tag every time it runs.
So, if I'm a user and I really want to make sure I'm running the latest version of a tool, say a weather MCP server that just got a critical API fix, what are my options? Do I have to go hunt down the npx cache folder and delete it like a caveman?
You can do that, but it's not elegant. The correct way to force it via the command line is using npx-no-cache. But here's the kicker. Many AI agent config files don't easily allow for passing those kinds of flags through to the npx execution layer, or if they do, it's not clear. And if you use --no-cache on every single run, you're adding a massive latency penalty to every time your agent starts up. It has to hit the network, hit the registry, check the metadata, potentially download the tarball. You're turning a sub-second startup into a 5-second startup.
I can see why developers are starting to look at alternatives. You mentioned some people are moving toward precompiled binaries or other registries. Is NPM just the wrong tool for this?
It's not that it's the wrong tool, it's that it's a tool being used for a purpose it wasn't quite optimized for. NPM was built for build time dependencies. You download your packages, you build your app, you deploy. NPX was built for one-off CLI tools. Using it as a service manager for background AI tools is a bit of a stretch. That's why we're seeing the rise of things like UVX in the Python world. UV is a tool written in Rust that is significantly faster than NPM, and its handling of ephemeral environments is much more predictable. When you run something via UVX, it's nearly instantaneous, and it's much better at ensuring you're getting what you asked for without the weird stale cache issues that plague the NPM CLI.
And then there's the binary root. If I ship a Go or Rust binary, I don't have to worry about the user having Node installed. I don't have to worry about the npm cache. But I lose that one command to rule them all, convenience of npx.
You also lose the community trust of the NPM registry. For a lot of developers, npm install or npx is the gold standard for safety, even if that safety is somewhat illusory. There's a psychological comfort in seeing a package on the registry. But we have to talk about the security side of this stale problem too. If a developer discovers a remote code execution vulnerability in their MCP server, which, remember, has access to your local files in your shell, and they publish a fix, the silent stale. Behavior of NPX means that a huge percentage of their user base remains vulnerable for 24 hours or more. There is no auto-update mechanism that pushes the fix to the agent.
That's a scary thought. In a world of autonomous agents, we're essentially creating a massive decentralized network of unpatched software. If the agent is the one deciding when to run the tool, and the tool is cached and vulnerable, the user might not even know they're at risk until it's too late.
It's a major hurdle for the ecosystem. Some community members are trying to fix this. There's a tool called MCP Server Updater that basically scans your Claude desktop configuration, looks at all the NPM packages you're using, checks the registry for newer versions, and then manually updates your config or clears the cache for those specific packages. It's a patch for the patch.
It's funny how we always end up building more tools to manage the tools we already have. It's like the nodemon for MCP servers.
Actually, that exists. It's called McPmon. Developers use it during the dev cycle so they don't have to keep restarting their agent every time they change a line of code. But that doesn't help the end user. The end user is just stuck with whatever NPX decided to keep in its pocket that morning.
So, if you're a developer listening to this and you're about to ship your first MCP server to NPM, what's the hierarchy of needs? What are the must-dos to avoid these pitfalls?
First, include the -y flag in every single piece of documentation. If you show a config snippet, make sure it's npx-y your package. Second, be very clear with your users about how to update. Don't just say it updates automatically. It doesn't. Tell them they might need to run a specific command to clear their cache if they don't see the new features. Third, consider version pinning in your recommended config. Instead of telling people to use at latest, tell them to use at 1.2.3.
Wait, doesn't pinning make the update problem worse? Now they're stuck on an old version forever until they manually change the string in their JSON file.
It's a trade-off, but it's an honest trade-off. If you pin the version, the behavior is deterministic. The user knows exactly what they are running. When they want to update, they explicitly change the version number. This avoids the ghost tool bug, where the agent thinks it has version B, but is actually running version A. In the world of AI, where the interaction between the model's instructions and the tool's capabilities is so fragile, determinism is often better than convenience.
I see that. It's better to have a tool that works consistently on an old version than a tool that might or might not be on a new version with a broken schema. It's about reducing the state space of what can go wrong. If the agent knows it's talking to version 1.0, it won't try to use version 2.0 features.
Precisely. Well, not precisely, I mean that's exactly the logic. It also helps with debugging. If a user reports a bug and their config says at latest, you have no idea what they're actually running. If their config says at 1.0.5, you can actually reproduce the environment.
Let's talk about the registry itself. NPM has been around a long time, but it's evolving. I heard something about provenance features coming to NPM. How does that change the trust model for MCP?
This is a big deal for 25 and 26. NPM provenance allows you to link a published package directly to the source code and the build process, like a GitHub action. So, when an agent pulls an MCP server, it can, in theory, verify that the code it's about to run was actually built from the official repository and hasn't been tampered with. For an AI agent that might be pulling tools dynamically in the future, this kind of cryptographic proof is going to be essential. You don't want your agent hallucinating a tool that turns out to be a malicious NPM package with no source history.
So we might move to a world where the agent itself checks the provenance before it agrees to run NPX. Like, I see you want me to use this Google Maps MCP server, but the NPM signature doesn't match the official developer's key, so I'm skipping it.
That's the dream. But we're still fighting the cache first. It doesn't matter how good the provenance is if the agent is running a version from 6 months ago that doesn't even have the provenance metadata.
It's always the plumbing. It doesn't matter how fancy the faucet is if the pipes are clogged with old versions.
It really is. And for developers, I think there's also a lesson here about bloat. Part of the reason NPX is slow and relies so heavily on caching is that NPM packages can be massive. You're downloading node modules. You're setting up a whole environment. If you're building an MCP server, keep your dependencies light. The smaller your package, the faster that cold start is, and the less painful it is for a user to bypass the cache.
That's a good point. If your MCP server is a single file with 0 dependencies, NPX is a breeze. If it's a 300 megabyte monster, you're basically forcing the user to rely on the cache just to keep their agent responsive.
And we're seeing the binary revolution happen for exactly this reason. Go and Rust are becoming very popular for MCP servers because you can ship a single, small, statically linked binary. No node, no npm, no node modules folder. You just run it. The startup time is in milliseconds, not seconds.
But even with a binary, you still have the "how do I get this onto the user's machine?" problem. That's why NPX is so addictive. It's the delivery mechanism that's the killer feature, not the runtime.
It's the app store for the command line. And until someone builds a better, faster, more AI-aware version of that app store, we're stuck navigating the quirks of the NPM cache.
So, for the developers out there, what's the pro move for testing this? If I want to see if my update is actually going to hit my users, how do I simulate that?
The best way is to actually go through the pain yourself. Set up a test MCP server on npm. Hook it up to your Claude desktop config using npx. Then publish a small change. Maybe just change a log message or a tool description. Restart Claude. See if the change appears. Most developers will be shocked to find that it doesn't. Then try to figure out what it takes to force that update. Usually it involves npx clear, npx cache, or manually deleting folders. Once you feel that frustration, you'll write much better documentation for your users.
It's like the old saying, if you want to understand someone, walk a mile in their cached NPM directory.
Something like that. I think we're also going to see AI agents get smarter about this. I wouldn't be surprised if future versions of Claude or Cursor include a check for tool updates button that handles the npx cache invalidation for you. They have to, because the current experience is just too broken for non-technical users.
Imagine explaining the NPX cache TTL to a lawyer who just wants to use a legal research MCP server. It's not going to happen. They're just going to say, the AI is broken, and stop using it.
And that's the real risk. The technical friction of the distribution layer could stifle the adoption of the protocol itself. We need the "it just works" experience of a smartphone app update, but right now we have the compile it yourself and pray the cache is fresh experience of the early Linux days.
It's a classic growing pains moment for the agentic age. We're building the future on top of tools that were designed for a different era. But hey, that's where the opportunity is. If you can solve this seamless update problem for MCP, you've basically solved the distribution problem for the next generation of software.
There's also an angle here about registry drift. Sometimes a developer unpublishes a version or the registry has an outage. If your agent is totally dependent on npx for a core tool and npm goes down, your agent loses its hands. It can't talk to your database, it can't check GitHub, it's effectively lobotomized. This is why some enterprise users are looking at local installs or private registries.
Lobotomized by a registry outage is a great title for a tech thriller, but it's a real concern for production deployments. If you're running an AI agent that's handling customer support or automated DevOps, you cannot rely on an ephemeral MPX cache and a public registry. You need those files local, pinned, and verified.
Which brings us back to the NPX is for one-offs, not for production, rule. It's great for the Getting Started guide, but for any serious use case, you should probably be installing that MCP server as a global package or managing it via a dedicated tool that gives you more control over the lifecycle and updates.
Let's pivot to the practical takeaways for a second. We've painted a bit of a grim picture of the silent stale problem, but what are the wins here? What can a developer do today to make their NPM-based MCP server stand out?
Beyond the -y flag and the version pinning, I'd say implement a version tool inside your MCP server. Let the agent call a tool named getServerVersion. That way, the user can literally ask the agent, hey, what version of the GitHub tool are you running? The agent calls the tool, the server reports its internal version number, which you hardcode in your build, and the user can see if it matches the latest release. It brings visibility to the invisible layer.
That's brilliant. Use the protocol to debug the protocol. If the agent can report back, I'm running version 1.0, but I see in my context that version 1.1 is available, it can even tell the user how to fix it.
I mean, that's a great idea. It turns the agent into a code debugger. You could even have the server check for updates itself, though that gets into some weird phone home privacy territory that some people might not like. But at the very least, having the server be self-aware of its version is a huge step forward for transparency.
And from the user side, if you're listening and your AI agent is acting up, the first thing you should do before you blame the model, before you rewrite your prompt, is just try to clear that NPX cache. It's the turn it off and back on again of the AI tool world.
It really is. On macOS, it's usually in users, your name.npm_npx. Just blow that folder away and restart your agent. 9 times out of 10, that weird bug that the developer said they fixed will actually be fixed.
Well, this has been a deep dive into the pipes. I think the big takeaway is that convenience in the developer world often comes with a complexity tax that the end user ends up paying in the form of stale code and silent failures.
And as the MCP ecosystem matures, we're going to have to move past the just NPX it phase and into something more robust. Whether that's a dedicated MCP package manager or just better integration in the agents themselves, the silent stale problem has to be solved for this to go mainstream.
For sure. Alright, I think we've covered the registry, the cache, the headless hang, and the ghost tool. Bugs. If you're shipping to NPM, be careful, be explicit, and for the love of all that is holy, use -y.
And don't forget to mention that version pinning is your friend, even if it feels a little old-fashioned. Determinism is a feature, not a bug.
Spoken like a true nerd. Thanks for the breakdown, Herman. I actually feel like I understand why my Claude desktop was acting weird yesterday. It was probably a 3-day-old version of a tool I thought I updated.
I'd bet my last carrot on it.
We should probably wrap this up before your MPX cache expires, and you start repeating yourself. Big thanks to our producer Hilbert Flumingtop for keeping the show running smoothly behind the scenes. And a huge thank you to Modal for providing the GPU credits that power this whole operation. It's pretty wild that we can have these deep dives powered by the very tech we're talking about.
It's a virtuous cycle, or a recursive loop. Either way, it's fun.
This has been my Weird Prompts. If you find the show useful, or if we helped you fix a stale MCP server today, leave us a review on Apple Podcasts or Spotify. It actually makes a huge difference in helping other developers find us.
And you can always find the full archive and all the links we mentioned at myweirdprompts.com.
See you in the next one.
Stay fresh, everyone. Don't let your cache get stale.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.